So actually, I want to start going back to this slide and saying, just to make sure we're on the same page, in the animals unit, let's talk about what are the observations, what are the patterns, and what are the models. So they're doing the mealworms investigation. And as they're doing the mealworms investigation, they're doing the inquiry. They're going up. So they're going from observations to finding patterns to learning about scientific models to explain those patterns. So what are the observations? You know, what are they doing that's observations? That's a question for you, yes.
We find the mass of the potato and the worms.
Right. They're collecting data about mass and data about BTB color change, right? So those are the observations, and they end up with a bunch of observations. They measured mass at different times in different ways and observed the BTB. So then what are the patterns in those observations that we need them to notice in order to go on to the models?
Change in mass.
Okay, what about the change in mass?
Does something lose mass? Does something gain mass?
Mm-hmm.
Does the container, like, a lot of my kids try to talk about, like, the container, BTB changed color, like, why did the BTB change color, where did it come from?
Yeah, so one pattern is about the BTB, and the BTB always changes from blue to yellow, and that's indicating more carbon dioxide. So what's the kind of key things they have to notice? What are the key patterns they have to notice about the mass changes?
The mass of the potato goes down and the mass of the worm goes up. However, the potato mass goes down more than the worm goes up.
Yeah, and that's true even if you take the worm's feces and those other things, as Heather was saying about the container, that everything inside the container is somehow going down, which is to say something is escaping from the container that was there before. Okay, so and then what are the models? And I point out that oftentimes we talk about kids developing their own models. In carbon time, we don't expect kids to develop their own models. Instead, we're teaching them to use scientific models. And what are the scientific models that we're teaching them to use?
The pictures, right? The pictures of all the ones, the plastic.
Yeah. Yeah, so atomic molecular models, right? And we have several representations. We have the atomic molecular models, and we have the chemical equations, and we have the little animations on the PowerPoints, and those are all representations of atomic molecular models.
So you're saying you would consider the equation a model?
Yes. It's a representation of a model. The model is bigger than that, but it's kind of like the equation is saying, this captures something important about what's going on from an atomic molecular perspective.
Which one has the coins? Is that the animal?
Yeah, that's sort of a simplified version of the model, right? The pennies and nickels are little molecules and big molecules, and saying, we don't want to mess you up with all of the C's and H's, but this is. Okay, so this is the general picture then, that every unit is like this, that it involves observations and key patterns that kids find in the observations. And the models always are the same. It's always coming back to these atomic molecular models of the processes. So that's the context in which we're thinking about these practices in carbon time. So evidence-based arguments, and notice that evidence-based arguments and explanations contain a lot of the same content, but they're different starting points and going to different places. So the evidence-based arguments, that you start out with patterns in data, and you're trying to develop model-based explanations. And so the direction is patterns in data, models unknown, move to where you end up with some kinds of tentative explanations and unanswered questions that the kids don't know enough to fully develop the scientific model. So they end up with some unanswered questions. Then explanations is moving the other direction. That this is saying, okay, you know the model, now here's a new phenomenon. You know, that the mealworms are growing, the mealworms are moving, the mealworms are digesting food. Let's see if we can use the model to explain that. So it starts with the model known, and then the phenomenon is the new thing that somehow you have to explain. So that's kind of the basic distinction between evidence-based arguments and models. Make sense? And this is my last slide. So CER is a really big deal in some school districts. Have you got people in is your school district kind of big on CER? There's some school districts where it's a big deal. And you hear a lot about it. And often, and these are the definitions from an NSTA rubric for evaluating CER. It says a claim is a statement or conclusion that answers a question. Evidence is scientific data that supports the claim. And reasoning, a justification that connects the evidence to the claim. It shows why data counts as evidence by using appropriate and sufficient scientific principles. So those are one of those, they're simple little looking definitions that all of a sudden turn out to be a whole lot more complicated when you try to apply them to the real world. And my critique of these is they are not specific enough. You know, it's kind of like, how many different questions are there in the world, and therefore how many different answers to those questions? How is that useful for actually identifying a claim when you've got kids trying to write claims, evidence, and reasoning? And similarly, the definitions of data, of evidence, and especially the definition of reasoning, turns out to be, reasoning that I'm thinking you need something more specific than that if you're going to actually help kids, coach kids, help them get better at claims, evidence, reasoning. So that's what we've been trying to do in Carbon Time, is saying the claim that we're aiming for in the investigations is a tentative model-based explanation. They're trying to answer the three questions, to say what's happening to matter, what's happening to energy, what kind of transformations are taking place. And then the evidence are the patterns in the data. And the reasoning has two parts. And this is one of the things that reasoning, the people who invented claims evidence reasoning kind of took these two parts and collapsed them into one. And I've always felt like that's a problem. That one part is what is typically called the warrant. And that's what's the logical connection between the claim and the evidence. And the other part is the backing, which is what's the theory that underlies that logical connection. So in this case, the backing is atomic molecular theory and conservation of matter and energy. And that backing justifies the warrant that says, okay, if the container is losing mass, then somehow matter must be moving out of the container. Because we know that the container can't possibly lose mass in any way other than matter leaving the container. And therefore, if we have a pattern where we say the container is losing mass, then we can logically conclude that matter is moving out of the container, and that in turn leads us back to a claim about what's happening to the matter, the mealworms and so forth inside the container. And so for the animals investigation, we're hoping that the claim, and again, it's, tentative explanation, unanswered question. So eventually, we want the claim to be, this is the process of cellular respiration, and this is what the mealworms are doing with the food that's resulting in the production of carbon dioxide that's leaving the container, and that's why the container is losing weight.
I think
the other thing that I imagine is showing up for you as Andy talks about this is that the CER framework, if it's important for you individually or your school to be using, matches best with the evidence-based argument tool. Well, it can match well with the evidence-based argument tool. There are also ways to match it with the explanations tool. But if you're struggling and it's important for you to make a connection based on this, I think you can see where, like in the evidence-based arguments tool, you have the conclusions, which is the claim, and of course the evidence, the patterns and evidence. So those things are sort of like established for you already.
More the latter.
Okay.
That saying, although we deliberately did not use CER language for the EBA tool, but we included CER components in that tool.